Good day, everyone. Welcome to I Square Maths Academy, where numbers and variables actually mean mastery. Today, we are going to be solving ordinary differential equation of the first order using direct integration method. Yes, in our last section, we actually looked at solving differential equation using the separation of variables method. But today, we are going to be applying the direct integration method. Let's get started. Now, looking at this now, these are examples. Now, example one, we have 5 questions under example one. Yes. Now, the first one here is question A. So here we have x squared, the y all over the x is equal to x squared sine 3x plus 4x. Yes. Now, the first step here is to isolate the y all over the x. Yes, to make the y all over the x exist alone. So it means in this case, we are going to divide. Yes, we are going to divide through by x squared. Yes, so dividing through by x squared, we have x squared, the y all over the x, divide by x squared is equal to x squared sine 3x plus 4x all over x squared. Yes, so we are dividing through by x squared. So it therefore implies that here, this x squared will go with this x squared. And here will be left with just the y all over the x. Yes, at the left hand side. So we have the y all over the x. Now this will be equal to, we have x squared sine 3x all over x squared plus 4x all over x squared. Now, this x squared will go with this x squared. So here, the y all over the x will be equal to, we have sine 3x, then here we have plus. Now, this x will go on with one of this x, will be left with 4 all over x. Yes, so the y all over the x is equal to sine 3x plus 4 all over x. Now, the next step is to integrate both sides. So now, integrating both sides. Yes, so now we are integrating both the left hand side and of course the right hand side. It therefore means that here we have integral the y all over the x, then x, because we are integrating with respect to x. Now it's equal to, here we have integral sine 3x plus 4 all over x, then here we have dx. Yes, so it means here we have integral, the y will be equal to, we have integral sine 3x dx plus integral 4 all over x dx. Yes, so when you integrate the y, it gives y. Yes, when you integrate the y, it gives y. So here, this is equal to, now let's do this integral sine 3x. When you integrate sine 3x, it will give minus cos 3x, then you multiply it by the derivative, 1 all over the derivative of the function, 3x. So it will be 1 all over, when you differentiate 3x, you have 3. Yes, that's for this. So here we have plus. When you integrate 4 all over x, it gives 4 ln x. Then here we have plus c. So it means our y will be equal to minus 1 all over 3 cos 3x plus 4 ln x. Then here we have plus constant. Yes, so that's what y. So this is the equation. Okay, yes, this is the equation. Now let's move straight to question number 2. That's B. So here we have B. Yes, we have B. Question B. we have x, the y all over the x is equal to, we have x squared plus 2x minus 3. Yes. Now the first step is to divide through by x. So here we divide through by x. So dividing through by x, we have x, the y all over the x. All over x is equal to x squared plus 2x minus 3 all over x. Yes, all over x. So now this x will go with this x. Yes, x will go with this x. And we'll be left with the y all over the x. The y dx will be equal to, now here we have x squared all over x plus 2x all over x minus 3 all over x. Yes, so it therefore means that the y all over the x, the y all over the x will be equal to x squared divided by x is x plus 2x divided by x is 2. Then we have minus 3 all over x. Yes. Now the next step is to integrate both sides. So integrating both sides, So here we have integral the y all over the x with respect to x is equal to integral x plus 2 minus 3 all over x dx. So here this x, the x will go with this. So we have integral the y will be equal to integral x plus 2 minus 3 all over x dx. So here when you integrate the y, remember we said integration is the reverse aspect of differentiation. So it therefore means that when you integrate the y, it gives y. Yes, it gives y. Now when you integrate x, it gives x raised to the power 1 plus 1 all over 1 plus 1. Then plus when you integrate 2, it gives 2x minus when you integrate 3 all over x, it gives 3 ln x. Then here we have plus c. It therefore means that our y will be equal to x raised to the power of 2 all over 2 plus 2x minus 3 ln x. Then here we have plus c. So this is the value of y. So that's question B. Now we are moving straight to question C. Yes, question C. Now, question C, we have x squared. Yes, C. We have x squared. The y all over the x is equal to, we have x squared sec square x plus 5x. Yes, plus 5x. Now, the first step here is to divide through by the coefficient of the y all over the x. And as we can see, the coefficient of the y all over the x here is x squared. So here you tell them divide through by x squared. So it therefore means that we are dividing both left hand side and right hand side by x squared. So here we have x squared, the y all over the x divided by x squared is equal to, we have x squared sec square x all over x squared plus 5x all over x squared. So this x squared will go with this x squared. And we'll be left with the y all over the x will be equal to this x squared will go with this. Here we have sec square x plus, now let's look at this. X will go with this x squared. Here will be left with x. So here we have 5 all over x. So now, moving forward, the next step is to integrate both the left hand side and of course the right hand side. So now let's call this integrating both sides. Yes, integrating both sides. Now when you integrate both sides, it means we have integral the y all over the x with respect to x is equal to integral, we have sec square x plus 5 all over x. Then here we have the x. So it therefore means that here we have integral dy. Yes, because looking at this, we have the x, we have the x here, we have the x here. So this will actually go with this. So we left it integral dy is equal to integral. So here we have sec square x plus 5 all over x dx. Please take note, this is 5. Yes, plus 5 all over x dx. Now when you integrate the y, it gives y. Yes, when you integrate the y, it gives y. When you integrate the x, it gives x. So it therefore means that here we have y is equal to integral sec square x dx plus integral 5 all over x dx. So it means y will be equal to, when you integrate sec square x, remember when treating differentiation, we said when you differentiate tan x, it gives sec square x. So since integration is the reverse aspect of differentiation, it means when you integrate sec square x, it gives tan x. So here we have tan x plus, now when you integrate 5 all over x, it gives 5 ln x. Then we have plus c. So this is the value of y. Our y is equal to tan x plus 5 ln x plus c. So that's question C. Now let's move straight to question D. Yes, question D. Now question D, we have cos square x. We have cos square x, the y all over the x is equal to, we have 1 plus cos cube x. Yes, cos square x, the y all over the x is equal to, in bracket 1 plus cos cube x. Now the first step is to divide through by the coefficient of the y all over the x. And as we can all see, the coefficient of the y all over the x is what is attached to the y all over the x. And what is attached to the y all over the x is cos square x. So here you tell them, divide through by cos square x. So here we have cos square x, the y all over the x, divided by cos square x will be equal to, we have 1 plus cos cube x. Yes, now divide by cos squared x. Yes, now this cos square x will go with this cos square x, and will be left with the y all over the x. So the y all over the x will be equal to, we have 1 plus cos cube x all over cos squared x. Yes, the y all over the x is equal to 1 plus cos cube x all over cos squared x. So now, what we're going to get here is the y all over the x. The y all over the x will be equal to, we have 1 all over cos squared x plus, we have cos cube x all over cos squared x. Yes, that's the y all over the x. So it means here, the y all over the x will be equal to, remember in trigonometry, when treating trigonometry, we said 1 all over sine x is equal to cosec x. 1 all over cos x is equal to sec x. 1 all over tan x is equal to cos x. Yes, this cosec x is a short form of cosecant. Yes, just like we said, the sine is the full spelling here is S-I-N-E, that's sine. Yes, so sine is equal to the reciprocal of what? Cosec is the reciprocal of sine. So here we have cosecant, here we have secant of x, and here we have cotangent. Yes, cotangent of x. Yes, so 1 over sine x is cosec x, 1 over cos x is sec x, 1 over tan x is cot x. Yes, that's cotangent of x. So it therefore means that here we have 1 all over cos square x. So this will give us sec squared x. Then plus, remember this is cos cube x. So this will give us cos x. Because when you say cos cube x divided by cos squared x, this is like saying cos x times cos x times another cos x all over cos x times cos x. So this will go with this will go with this, and we'll be left with cos x. So that is exactly how we got the value cos x there. So it means now the next step is to integrate both sides. So you tell them integrating both sides. Yes. Now we integrate the left hand side, the y all over the x with respect to x. Yes, we are integrating with respect to x. Now is equal to, here we have sec square x plus cos x with respect to x as well. So here we have integral the y. Yes, because looking at this, the x will go with the x, so we'll be left with the y. So integral the y will be equal to integral, we have sec square x plus cos x, then here we have the x. So when you integrate the y, you have y. When you integrate sec square x, it gives us tan x. Because when you differentiate tan x, it gives sec square x. So it means when you integrate sec square x, it gives tan x. So here we have tan x plus, now when you integrate cos x, it gives sin x. Then here we have plus constant. So this is the value of our y. Y is equal to tan x plus sin x plus constant. So that's question D. Now we're moving straight to the last question there, which is question E. Yes, question E. Now let's look at this. Now question E, we have the square root of 1 minus x squared, the y all over the x, the y all over the x is equal to 1. So in this case, the first step we said is to divide through by the coefficients of the y all over the x. And of course, we can see there that what is attached to the y all over the x is the square root of 1 minus x squared. So here, we are dividing through by the square root of 1 minus x squared. Now, it means here we have, for the left hand side, we have 1 minus x squared, the y all over the x, divided by the square root of 1 minus x squared is equal to 1 all over the square root of 1 minus x squared. So this will go with this. So we left with the y all over the x. So that will give us 1 all over the square root of 1 minus x squared. So here we are to integrate both sides. Yes, that's the next step. So integrating both sides. Okay, so it means now we are integrating both the left hand side and of course the right hand side. So it means here we have integral the y all over the x with respect to the x is equal to integral 1 all over the square root of 1 minus x squared. Then here we have the x with respect to the x. It means here we have integral dy. Yes, because of the x will go with the x there. So we have integral dy. Yes. So here we have integral dy is equal to integral 1 all over the square root of 1 minus x squared dx. So here it means when you integrate the y, that will give us y. Yes, when you integrate the y, it gives y. Now let's look at the integral of this. Now please let me take us back to integration, differentiation of inverse trigonometry functions. Remember we said if y is equal to the sine inverse of x, that the y all over the x is 1 all over the square root of 1 minus x squared. If y is equal to cos inverse of x, we said the y all over the x is equal to minus 1 all over the square root of 1 minus x squared. And we said if y is equal to the tan inverse of x, that the y all over the x is equal to 1 all over 1 plus x squared, or x squared plus 1. Now let's look at this. What we have here now is the integral of 1 all over the square root of 1 minus x squared. So now remember we said integration is the reverse aspect of differentiation. So it therefore means that if looking at this, we'll see that it actually tallies with this. So it means y now, when you integrate this, it gives us sine inverse of x. Then here we have plus c. So this is the value of y. So y is equal to sine inverse of x plus c. So now we have seen how to solve or analyze ordinary differential equation, first order ordinary differential equation to be specific, using the direct integration method. So in our next section, we are going to be looking at how to use the integrating factor, because I did mention 4 methods: the separation of variable method, the direct integration method, using the integrating factor method, and of course the linear equation method. So we have actually seen the separation of variable method, and we have also seen the direct integration method. So in our next section, we are going to be looking at applying the integrating factor. So if you enjoyed this video, remember to like, share, and subscribe for more classes on differential equation. Thank you so much for listening, and God bless you.